Greetings. Welcome to today's lesson on solving systems of linear equations using elimination when you have to multiply first. Okay, this is actually going to harken back to basically about the fourth grade. Okay, when you first learned how to add and subtract fractions. It's really the same skill, just applied to a new setting. Okay, so let's go back and take a quick look at what that looked like back in the day. When you first learned how to add and subtract fractions, we started you off real easy with things like this. And the reason it was so easy was that the two denominators were already the same. So all you had to do was add the numerators. Okay? So that was a pretty straightforward one. You learned that pretty quickly because it was already set up for you. You just had to add the numerators as long as the denominators were the same. But what happens when one of the denominators is not the same? What did we do then? Well, it wasn't that big a difference. What we then had to do is we had to change one, sometimes both, of the denominators so that we had what we called a common denominator. Meaning, what did 2 and 4 share as a factor? We would multiply the top and the bottom by something, and then we had that common denominator and we were ready to go. We could simply, again, add the numerators. Now, we're going to see that exact same set of skills. The only thing I'm going to change is instead of the word denominator, I'm going to use the word coefficient. So we're looking for the number that's in front of one of the variables, either x or y, and we're going to want to change it to be the same as the one in the other equation. So just like I wanted to change one of the denominators to be the same as the other fraction's denominator, I'm going to want to change the coefficient in front of one of the variables to be the same coefficient as in the other equation. So let's see how that looks. So again, we're just going to solve because we're trying to find out where they meet. And we have the two equations, 6x plus 5y equals 19, and 2x plus 3y equaling 5. So those are our two equations. And as you can see, they're already in the same format, so that at least saves me the step of having to rewrite them in the same format, line them up, remember arranging them in columns. We'll see one like that in just a moment. All I have to worry about is that they don't have the same coefficient. They have no coefficient in common. So I have to do something so that there is a common coefficient. Now the nice thing here is it doesn't matter which coefficient I decide to target, and it doesn't matter whether I aim for them to be the same or whether I aim for them to be opposite. I can decide either one. It's flexible in that regard. So I look, generally speaking, again, I would always go after the smallest coefficient because it's usually the easiest to change. And I would look, does it look like I can turn 2 into 6 very easily? Yeah, probably. Certainly easier than turning a 3 into a 5. So what I'm going to do is I'm going to multiply the entire equation by whatever number it takes to turn 2 into 6. Well, I know that's a 3, so it's a pretty easy number. Now, I could make it a -3, but I'm going to hold off doing that for right now. The other thing is I could have multiplied so that the y's were the same, but this is easier because I only have to multiply once. I multiply all the numbers. Just like when I was doing the fraction, I multiplied the top and the bottom, the numerator and the denominator. Here I multiply the left and the right side of the equal sign. So essentially the only thing that has changed is instead of having a fraction being top and bottom, now I'm going left and right. So I'm going to multiply 3 times 2, it's going to get me 6x. 3 times 3 is going to get me 9y, and 3 times 5 is going to get me 15. And now I can bring this equation down here, 6x plus 5y equals 19. And now, look at what I have. I have two coefficients with the same variable that are the same. Now I'm ready to eliminate. I'm ready to subtract because they are the same. So again, I'm going to remind myself I'm going to subtract here, here, and here. 6x minus 6x is going to leave me with 0, so that's going to be gone. 9y minus 5y is 4y. And 15 minus 19 would be negative 4. And again, now I'm so close to being finished. So easy. Simply divide by 4, and y equals negative 1. And again, now I'm going to be able to place it back into either equation. Now, I would never place it into one that I have modified. I would always go back to the original. In this case, probably even easier to go back to the alternative, the equation that I didn't do anything to. But there may be a time when you've done something to both equations, but you would always go back to the original. So let's do that. So 6x plus 5 times negative 1 equals 19. And now we're solving equations just like we did back in the day. Add 5 to both sides. 6x equaling 24, dividing by 6, and x equaling 4. And now I have a final answer of 4 comma negative 1. And again, I could have placed this negative 1 into this equation. I assure you it would give me the same result. And if you're not sure, try it. That's the beauty of this. If you plug it in, if you plug negative 1 in here, and both times you get the number 4, there is no doubt that you have the right answer because you have shown that the point 4 comma negative 1 is a point that is on both lines. And that is the key to finding the solution to a system of linear equations. If the point is on both lines, then it has to be the point that is where they intersect, because there's only going to be one. There can never be more than one when we're dealing with linear equations. Okay, there could be 0, and we'll talk about that in our next lesson. Okay, but there could not, but it's 1 or 0. Well, there's another weird one. We'll see that also in the next lesson. But for our purposes, we're looking for that one spot where they intersect. Okay, because we're not dealing with curves. Nothing comes back on itself. These are straight lines that can only touch once. So if 4 negative 1 is on this line and 4 negative 1 is on this line, that is the place where they meet. Now obviously graphing this would probably be rather horrible. I would have horrible fractions, I would have horrible lines, I'd have horrible numbers. I wouldn't want to do it. Okay? Even substitution, probably not the optimal way to go. That's why elimination is so wonderful. It works every time, it works with any set of numbers, and if they're not agreeable, you multiply, just like you would do with fractions. You had 2 fractions that didn't have that common denominator. What would you do? You would multiply one of those 2 fractions, or both, to get that common denominator. Okay, so let's take a look at one more example. And again, we're just going to keep that solve. That's our only goal here. Find the solution, find that spot where the 2 lines intersect. Okay, so we have 4x plus 5y equals 35, and we have 2y equals 3x minus 9. Now this one's tricky because there's all kinds of problems. First of all, they're not lined up. I don't even really want to start until they are. So I want to get this into this form because standard form is my ideal form for this problem. Anytime I'm using an elimination, I like to be in standard form. So this one's already in standard form, so I don't want to mess with it. I want to mess with this one. But it doesn't take much. I just have to subtract 3x from both sides. I get negative 3x plus 2y now equals negative 9. Well, I'm going to write this one right under here. So it's negative 3x plus 2y equals negative 9. Well, I don't have anything in common. I don't have an easy fix. I can't turn a 3 into a 4 very easily. I can't turn a 2 into a 5 very easily. So I'm going to have to change both of these equations. Now, which one I want to do is completely up to me, or if you're doing the problem, it's completely up to you. Which ones do you want to change? This is the nice part. You can decide. I might want to change the x's, because then one would be positive and one would be negative, and I know if they're opposites, I get to add. And I'm always feeling safer when I'm adding. But 2 is pretty small, and 2 and 5 are really easy to convert. So then I might have the same y values, then I might subtract. So again, I really have the option to do either one. Okay? As you can see my little darling kitten in the background there. So I'm going to change them into opposites because I like adding. If I have my choice, I would always rather add. So I'm going to multiply the top equation by 3 because that'll give me 12x. And I'm going to multiply the bottom equation by 4 because that's going to give me negative 12x. So let's do that one thing at a time. So 4x plus 5y equals 35, and I'm going to multiply that whole thing by 3. So it's going to get me 12x, it's going to get me 15y, and it's going to get me 105. Okay? Now I'm going to do the same thing with the next equation. So negative 3x plus 2y equals negative 9, and I'm going to multiply that by 4. That's going to get me negative 12x plus 8y equals negative 36. And I'm always drawing those arrows to remind myself, especially so I get all the way out to the equal, past the equal sign. I have to include that. Okay, remember, equal signs mean it's like a balance. They're the same. If I multiply the left side by 4, I got to multiply the right side by 4. Okay, now I can bring this one down here. So I get 12x, I get plus 15y, and I get equals 105. And now I have, right here, I have my opposites. So I'm going to be able to add those up. And they're going to be gone. I'm going to add those, and I'm going to add those. 8 plus 15, that'd be 23y. And negative 36 plus 105 is going to be a positive 69. And now I'm, again, just like all the others, I'm almost done. I divide by 23, and all of a sudden, boom, there's my y value. That was nice and easy. Divided by 23, and my y was 3. Didn't look like it was going to be a 3 after doing all this and getting numbers like 105 and negative 36, but it was. So that certainly makes my life a lot easier. Now I'm going to take that and I'm going to go back to one of these two equations. Again, go to the originals. Don't go to one that you've multiplied. Don't go to the one you've rewritten. Go to the original problem. So I'm going to go to this one right here. Okay? In fact, I'm going to erase all of this. Bring just that y equals 3 up here. So, 4x plus 5 times 3 equals 35. 4x plus 15 equals 35. Subtract that 15. 4x equals the 20. Divide by 4. And x equals 5. Certainly didn't look like it when you first saw these two equations. But there it is. X is 5 and y is 3. And again, if I really want to be sure, and I almost always want to be sure, I want to be certain that I have done this correctly, I can plug this in to this equation to make sure it works. 2 times y should equal 3 times 5 minus 9. So does 2 times 3 is 6. Does 6 equal 15 minus 9? It sure does. And now I know I've done it correctly. Not a doubt in my mind that I have done this correctly. Okay? So this is what, and this is not easy. Don't get me wrong, this is not a simple task. Okay? To rewrite, now you have to do it all. You have to be able to rewrite the equations so they're in the same format, so they're arranged in columns, preferably standard form. It's almost always going to be the optimal form for this. Then you're going to have to multiply one or both of the equations so that they have a common coefficient. Either they share the exact same number or they're opposites. So they're the same, you can subtract them, or they're opposites so that you can add them. And when you do that task, they will go away. One of the variables. Doesn't matter which one, x, y, really doesn't matter, right? Found x first here. On the last one I found y first. It didn't make any difference. And it never will. Okay, so get them arranged in columns, multiply one or both equations so they have a common coefficient, add or subtract to eliminate one of the variables, solve for the remaining variable, substitute it back into one of your two original equations to find the other. Okay, not a quick, easy, but again, this is so we can find where two lines intersect without the need to graph, without even thinking about the graph, without worrying about slope or intercept or any of those things. Just using this process called elimination. But just like when you learned how to add a fraction, sometimes they don't have the same denominator. Here, sometimes they don't have the same coefficient. So you need to make sure that they do. All right? I hope that helps. And as I step forward, you'll see the same kitten in the tree. Isn't she adorable? And I'll see you guys in class.